Okay, I have 1K resistor and a coil. So coil from A1 to ground. So you cannot use breadboard with this coil, okay? Schematic is this electrical RL transient response. You need a 1K resistor, maybe. Okay, if you have something nearby, that's also okay. To connect that 1K from here to OD1. So RL transient circuit ready. So now this is with the coil, right? So it is too fast, so we will change the time base. So here you notice something different. When you go from 5 to 0 volt, the voltage is going to negative, right? We don't have a negative voltage as such. But immediately the voltage across the inductor goes to negative. That you must be knowing the reason, right? If the current is there, if current is suddenly withdrawn, there is a polarity reversal across the inductor, right? The back EMF develops. So now you can fit this exponentially and find out the inductance. So it says resistance of the inductor is something like 548 ohms and it is 117 millihenry. To make that a little bit more accurate, OD1 should be connected to A2 as well. Otherwise the OD1 is assumed to be 5 volt, but if you give it to A2, that will do a better measurement. See, it comes to 119. The actual value is around 120. Okay, so that means this experiment you can use something like to measure inductance, right? The inductance meter. So you wind a coil and you can measure the inductance. So now we have a commercially available inductor. It's a 10 millihenry inductor. So this also I can use. So let me just try this first. So here is midpoint. Resistance is coming from OD1 and then it goes to A1. OD1 comes to A2, but Now what is the connection left? Ground, right? Other end of the inductor should be grounded. Okay. Now clear all these things. So it goes, and this step it says 10.5 millihenry and 19 ohms, right? So you can verify that. And instead of 1K, if you want this, you can give a higher resistance here. So it will take longer. So I'll remove this and put a new resistor. Say a different one. Oh no, it's the other way. If you use a bigger one, it's not going to. It is R by L. So you need to go for a smaller one actually. So that's okay. Let's leave it. So now I'll again go back to the coil because we need to measure inductance of this coil. So all I have to do is again I have to use my 1K resistor. And A1 to ground is the, all of you are doing this, right? So we are back to this coil. So measurement gives us 118.8 millihenry. Okay. So this way you can measure inductance. Make an RL circuit, see that current waveform and fit it mathematically to get R by L ratio. R is known, so L is calculated. Now I will take another one. So you write it down. What is the value now? Just write it down. 118.8. All of you just write it down. 118.8. So now I'll put another one. Okay. So this is a different one. Okay, let us measure this. And 115.5. Write down that also. Now I am going to put two of them in series. One is there and another one is connected. Maybe I have to put a clip or something here, join it together. Just use a clip too. So now if I repeat the thing, what will be the inductance? See, what is the expected inductance in this configuration? What do we get? So again 235, is it tallying? 234.7, is it adding up? What are the earlier values? Yeah, and 115, what is it? 233, here it is, you are getting 34, okay. Within 1% it is all tallying, right? So note down this value also. Now we are going to place it like this. $191.8, write that also. Now change the orientation, take one more, analyze that, 274.7. So what are all the values we got? Can you tell me? Last three values. 274.7, and before that 191.8. Okay, put it as 7, 3. Right? Difference between the last two readings is 83, right? So what is L? L is equal to L1 plus L2 over plus minus 2M or M. What is it? Mutual inductance, right? So in one case it was minus, other case it was plus. So now take this 83 divided by 2 and see how it works out. All these values, you explain how it is coming. When the inductors were far away, it was Ln plus L2. Like this, one orientation, L1 plus L2 plus 2M, and then minus 2M. So that way you could measure the mutual inductance, right, by using two coils. And we are using 1 kilo resistor here. So if you substitute it, you get another value. It is 115 point something. Yeah, what is wrong?
My doubt is that if L by R is 0.072, R is the given resistance.
It is entered here. 1000.
If you multiply from that one, if you substitute R is equal to 1000, you will get L value as some 72 million.
Wait a minute. Is it L by R or R by L? Maybe there is a typing. Because what value you get is tallying, so only thing is you have to 0.072, right? Let me check. I am getting is 128 and so 0.128 divided by okay. You know why you are not? R is not 1K. What is the circuit total R? Around 500 something, that is there, right? That is showing here R inductance. You have to add that, yeah. R is not 1K. R is 1K plus the resistance of the coil. Yeah, then you find out what is it. So did all of you measure inductance? Is coming proper? Whatever is written on the coil, almost it is within a percent it should tally. Did I jump? Jamshias? ഇതൊക്കെ എവിടെയുള്ളത്? ഇതെല്ലാ കിറ്റിലും വരുന്ന സാധനമാണ് ഈ 10 മില്ലി ഹെൻറി. എല്ലാ കിറ്റിൻ്റെ കൂടെയും വരുന്നതായിരുന്നു ഈ 10 മില്ലി ഹെൻറി. അതെവിടെയുള്ളത്? എല്ലാവർക്കും ഓരോന്ന് കൊടുക്കണമെങ്കിൽ 1 മൈക്രോഫാരഡ് ആൻഡ് 10 മില്ലി ഹെൻറി. കിറ്റിൻ്റെ കൂടെ വരുന്നത്. Okay, now what we'll do is, but you have seen the transient response, right? And did you do the RLC transient response? I think first day we did it, right? Let me just repeat it. So we have seen the exponential nature of RC discharge and RL discharge. Now the next one is, you put everything together. This is having R and L. We will take a small c also. Okay, having a disc capacitor connected from ground to A1, and the coil is going to be connected from OD1 to A1. And now you go for electrical RLC transient response, and 5 to 0 like this. So what does this mean? Your circuit is here. So that means one end of the inductor, you first took it to 5 volt. What do you want? Then what happens? The current start flowing. It's a DC condition, right? And after a while you find that A1 will become 5 volt because other end is capacitor, right? Capacitor is fully charged. Then if you suddenly bring the other end of the inductor down to 0 volts, the capacitor voltage will not immediately become 0, it will gradually come, but here you find it is oscillating, right? So that means RLC circuit, there are 3 kinds of transient response. One is underdamped, other is critically damped and overdamped. So what is this one? Oscillating means underdamped, right? Underdamped means oscillations. Now you can fit it and find out the frequency. It says it is around 2 kilohertz and a damping factor of 125. So how do you increase the damping now? How do you increase the damping in a circuit, RLC circuit? You add some R, right? So I'll add some series. One more resistance let me put. So adding a series resistance should increase damping. Let's try it again now. Another measurement. See, it could not fit in because it has stopped oscillating, right? So maybe we could have probably put a smaller resistance and done it. Okay. So now let's go back to this. Is there any other way to increase damping? Oh, sorry, it's in the wrong place. What will happen if you increase the capacitance? See, this capacitance is very small, 0.04 microfarad or something. If I put a 1 microfarad, what will happen? So we can try this, and it is going to be heavily damped because the C by L value, square root of C by L, decides the damping factor. It's heavily damped, right? So these all you can try now. You must be having the coil, and all you need is a small capacity to give some small capacitor like this.